Dr. Sharan's academic journey is as impressive as it is inspiring. After earning his postgraduate degree in physics in 1995, he pursued his PhD in Geo-informatics in 2003 at the Indian Institute of Remote Sensing, ISRO, followed by advanced research at Wageningen University in Netherlands. With over 2 decades of experience at the ISRO, Dr. Sharan has made groundbreaking contributions in geoinformatics. His expertise spans distributed GIS, 3D city models, citizen science, geospatial modeling, and geohealth. Notably, he has led national biodiversity initiatives, including the development of the Indian Bioresource Informatics Network, that is IBIN, and collaboration between the Department of Biotechnology and the Department of Space. Dr. Sharan's contributions have been recognized with numerous prestigious awards, including the President Appreciation Medal in 2021, the National Geomatics Award for Excellence in 2019, and the Outstanding Contribution Award from the Asian Association of Remote Sensing in 2019. With over 100 peer-reviewed publications and guidance to numerous PhD students, he is also a highly respected academician. Beyond his research, Dr. Sharan has been a leader in various professional capacities, including serving as the Vice President of the Indian Society of Remote Sensing, Deputy General Secretary of the Asian Association of Remote Sensing, and Chair of the ISPRS Working Group on Applied Spatial Science for Public Health. Today we are privileged to have Dr. Sharan guiding us with his unparalleled expertise and insights. Please join me in giving a warm welcome to Dr. Samir Sharan. Thank you.
Thank you so much for the introduction. I'll be talking on the role of AI in remote sensing and geoinformation, which is anyway theme of this particular 1-week workshop on FDP. I think AICT sponsored FDP program. Well, if you look at AI in remote sensing, I think there are a lot of developments which has been taking place. And in fact, it is as it was said yesterday, that it's a game changer. And I would say there is a paradigm shift in the overall data processing, data dissemination, as well as data production. In all aspects, AI is playing a very important role. So what I thought is, I presume that I think yesterday most of the basics of AI, CNN, RNN already covered. Rather, I'll be sharing some of the use cases where Department of Space, ISRO, SAC, as well as NRSC has worked on those areas. And I would like to give you that in what applications this AI have been used. And of course, there are even much more potential which I'll be sharing with you today. So I'll be talking a little bit on the history of AI, then concept of AI, why AI is being used now in this particular era. Then machine learning. I think machine learning was already practiced a long back, I would say 10 years back. A lot of algorithms have been practiced in digital image processing, classification, regression. And apart from that, there are a few use cases which I have worked into. So that will give you a little bit of idea that how this machine learning approaches are giving you better results. There are concepts of CNN, RNN, and STM transformers and GAN. I presume that you know all those concepts. And then I'll just briefly touch upon, there are few use cases where Department of Space, SAC, NRSC, everybody has contributed on those areas. Well, artificial intelligence, I think you all know that there was always requirement by human that why can't we think like human? The machines should provide you a better intelligence as compared to human. So there was a scientist called Alan Turing. Have you heard about this Alan Turing? Alan Turing was, in fact, he's the person who first of all developed a mechanism that how the machine can give you better intelligence compared to human. So that was the test. He wanted to do that, but somehow he failed, maybe because of the less computational power of the computers. So that was the sad part of the story. So it is blinking. So basically you can see that he was the starting point. Alan Turing was the starting person who initiated, then followed by John McAfee. John McAfee also initiated on the artificial intelligence, and he also carried out one workshop, thinking machine, coined the term called artificial intelligence. So these are the two people behind the revolution, or I would say the beginning of the artificial intelligence. In fact, there were a lot of developments, like development of robot called Shaky. You can see that this particular robot is equipped with camera as well as computer, and it could able to automate, like it can do some basic work, but the actual human intelligence was not available in that particular robot. So you can see that in 1950 to 80, not much development have taken place. I would say that around 30 years, the government did not spend much funds on giving research in the area of AI. Then in post-AI winter in 1980 to 90s, there was some experiment done by Mercedes where they make a driverless car on a road, but it was not through different obstruction, rather they ran that car from one point to another without any obstruction. So that was the starting, that how the driverless car can be developed by making use of AI technology. And this was the project, like Project Deep Blue. Have you heard about this project, Deep Blue? That was the, I think it has, this particular project was the, I would say, triggering factor of AI in the world community. In fact, there was a chess competition between the computer program by IBM with Gary Kasparov. He was a world champion, world chess championship, and second time the computer could defeat Gary Kasparov. So that was that gives little bit of satisfaction that AI can really do wonders, and it can mutate human intelligence in various aspects. Then in AI growth 2000 and present, there are so many projects. Social robot is there. NASA developed Mars rover, Spirit and opportunity. Then Apple, Siri, and all those things. I think ChatGPT and all is all development. You'll be surprised to know that in Chandrayaan 3, landing was one of the most difficult part. And I think whether you have seen the live telecast of the landing, there were many, while landing it has to see the surface. So if there is any craters or if there is undulating surface, it is not going to land. So this entire operation was driven by AI based program, and those program was developed by the scientists of ISRO who could able to plan their landing in a very smoother way. Otherwise it would have happened the same way in Chandrayaan 2, where the landing was not so much successful. So that gives a brief understanding that we can make use of AI technology in order to provide better decision with respect to various applications. Now, I think you might be aware we have all these machine learning, deep learning, generative AI. Machine learning is basically a subset of AI, where what we do is we develop the algorithm and statistical models that enable computer system to improve their performance on a specific task through learning from data without being explicitly programmed. I think most of you are doing programming, and all these programmings are very task specific, right? So that's why but they are not scalable, right? If you apply a program to a particular data, if I talk about remote sensing, it can only be applied on a particular data sets. You cannot scale it, you cannot scalable, you cannot make it applicable to every different type of data sets. So, but nevertheless, if you learn your algorithm by making use of the existing data, then you can provide this application to many folds. Similarly, deep learning is much bigger. It's more, as name suggests, that it is a deep network. Means you have more number of network layers in order to train your model in a more, I would say, in a robust manner, and it can provide you better information. So I think computer vision and NLP are some of the areas where deep learning have been used. And similarly, you talk about generative AI, where you are trying to generate synthetic image. You might have seen there are so many generative AI videos, maybe when you see YouTube or so many different documentaries, you will see that people are making use of generative AI. They are generating the synthetic images. And only thing is, what is the, like, they look real in picture, but they are actually fake images. So a lot of generative AI's practice is there, and people are trying to really see that how we can get best possible information from the generative AIs. Now, why AI now? Well, this concept was, anyway, you can think that it could have been started long back, 20 years or 30 years before. But the reason is that now the computational power is very high. Now you have very good GPUs where you can process large amount of data, and you can able to provide in an optimal way, you can provide solutions. That is, the computational power is much more. You know that big data is also an issue, because big data, you cannot process big data on a conventional system. Conventional system in the sense that if you are working on a structured data, your programs are developed in such a way that you can store that data into RDBMS, and you can do any type of application, you can develop any type of application. But when you are talking about unstructured data, semi-structured data, or let us say structured data, as well as velocity, volume, veracity, all those aspects, if you have to really put them, process them together, it is very difficult. So you have to make use of AI in order to process those data, so that you are able to develop a number of applications. There are, internet anyway is providing the best mechanism it's a medium to disseminate the data. You have improved algorithm, and of course you have open source. So all these model diversity, complex models, more frequent updates, data diversity, and IT platform, all these development has ultimately evolved that AI can be used for different applications. Now, I was just giving you an example that how the traditional as well as the machine learning, how it is better than a rule-based system. Now, as you can see that in the traditional programming, you are making use of data, you define a logic, and then you do programming and you get the output. But what you do in machine learning is you have the data, you have the outputs, and then you train it, and then you get the prediction or classification, whatever type of algorithm you want to develop. So it is somewhat better approach as compared to the traditional systems. You can see that you, in a rule-based, you can apply a condition. If it is true, then it is case 1, code 1, and if it is false, then it will go to code 2. So this is the general approach which is being practiced among various programmers. But when you use machine learning, you have training data, you have machine learning algorithm, you have a model, you have new data, and you can do the prediction. So this is the advantage of making use of all these algorithms in order to have a better understanding. So what are the limitations, or I would say the advantages of using AI? First of all, manual interpretation. Like for instance at NRSC, you'll be, maybe you are not aware that we are creating land use land cover map for the entire country at regular intervals. Okay. Now, for 1:250,000 scale, we are, or let us say 1:50,000 scale, we are supposed to complete the entire processing of the data in 5 years of time. But we are not making use of AI. Reason is that we have to really go to some of the areas, the training data has to be collected, what all change has happened. So entire thing is manual intervention, although computer systems are being used. But if we try to make use of AI, if we are able to develop the training data of different land cover land use classes, and apply a deep learning algorithm or let us say machine learning algorithm, then our processing time is going to decrease many folds. Means within 1 year we are able to generate the data. But the problem, the limitation of doing these type of operation is we need to have a training data. If you look at the deep learning algorithms, most of the deep learning algorithms are run on the foreign training data, right? So nobody has created training data for our own country. You might have seen there are classification, or let us say there are training data available by China, by US, by Europe. But in India, I hardly see any good training data which can be used for machine learning algorithms or deep learning algorithms, right? So now NRSC is trying to develop I would say exhaustive training data of various land use, land cover classes. So if we have the training data available, the turnaround time will drastically reduce, and we will be able to provide this data, LULC, land use, land cover classification data of 1:50,000 within 2 years of time. Earlier we were taking 5 years, maybe once the data is ready, then even it may not be even 2 years, because only the validation, we need to check the uncertainty which are associated with those data sets. Remaining things, I think we are able to do it. So all these things will certainly improve if we start practicing AI in remote sensing. So, or let us say manual interpretation. Then simplistic algorithms, you are making use of simple maximum likelihood. If you are talking about supervised classification, you use a maximum likelihood classification. But when you are talking about unsupervised, or let us say you are talking about manual interpretation, you are doing just polygon, you are creating the polygon and then providing those labeled data to those polygons. So basically, if you make use of simplistic algorithm, they have got a lot of limitations. They may not work in the same area. Like some algorithm will work in some part of the country, some algorithm may not work in other part of the country. Because if you look at India, like this region has got a lot of mountains. The processing of this particular data will be totally different compared to southern part of the country, right? So you need to have different type of algorithms to train the data so that you are able to generate information. So limited scalability, manual or rule-based approaches are not easily scalable to handle large volumes of data. Inefficiency, traditional methods may require significant human effort to define. So I was telling that the turnaround time is going to increase if you make use of traditional approaches. But if you use machine learning, the turnaround time will be less, and your the data, the whatever outputs you will get, it will be highly, the accuracy will be much higher. Inability to learn, or lot of subjectivity is involved. Let me give you an example. If you make use of traditional method, if I give one satellite data to each one of you, everybody will come out with different land use, land cover map. Why? Because of your human interpretation, right? So in order to avoid those aspects, if you have the machine learning algorithm or deep learning algorithm, and everybody is making use of same model, then everybody will have the same output. So that subjectivity is going to drastically decrease if you make use of all these data sets. Yeah. Okay, now you can see that there are three broad categories under machine learning. You have supervised, you have unsupervised, and you have reinforcement learning. Supervised learning basically learns from the labeled data to map inputs to known outputs. So you can see that whenever you like to do training data, you try to train your data by providing the training sets, and those training sets are labeled, right? So they are nothing but more of a supervised learning. But unsupervised means you are making use of clustering, or there are so many algorithms by which you can directly generate the patterns, right? You have clusters with similar nature, and the clusters with similar nature can classify the entire information, right? Similarly, reinforcement learning is, it learns through interactions with an environment to achieve a goal. Like for instance, driverless cars, these are gaming. All these are reinforcement learning, where you are trying to develop from the environment. You try to learn your data with the help of the given environment. Okay, so you can see that the type of data is supervised, you have labeled data, unsupervised, you have unlabeled data, then type of problem, regression and classification. So you know the difference, what type of regression you are practicing in your day-to-day work?
Logistic.
Pardon?
Linear regression.
Linear regression. So in linear regression, what you do? You generally make a best fit line, right? But how do you come with that best fit line? What is the basis? What is the mathematical basis of generating a best fit line? Now, I want to be a little bit more interactive, no, so that how I'm deriving that best fit?
By comparison.
By comparison of, you have, everybody knows, no, you have scatter plot, let us say, and then you put a best fit line, and that best fit line is considered to be best fit. How it is best fit? I can draw a line little bit slanting. Why I am making that? What is the basis of making that best fit line? Any idea? See, what we are doing is we are calculating the residue for the individual point, right? So whenever we draw a number of lines, okay, and for every line the residue, that is the distance from the baseline to the point, will be calculated, and the sum of the square of the residual will give you some number. So the minimum residue you get for a given line is the best fit line. Okay, that is the basic logic of making a best fit line for a regression, right? Have you understood? So you have to calculate the residue for individual point, and after calculating the residue, you will see, and you sum all the residues, and for every line you have some number.
How to calculate residue?
See, residue, it is, maybe I can give you the formula. See, if you have a point like this point, okay, so there is a line, okay, let us say this is a reference line, okay, so the point, the distance from this point to this point, okay, that is square of this distance, okay, similarly for this point and this point. So for this particular line, like let us say this is the reference line, and I will calculate the residue for all these points, okay, and if we tilt this, maybe I can.
Is it Euclidean distance?
Huh?
Is it Euclidean distance? Is it Euclidean distance?
No, it's not a Euclidean, it is sum of squares.
Sum of square.
Sum of squares. Maybe I can show you one example. I think I have that slide. So this is the finding the best line. So you can see that you can have, now this is the best line, right? There could be this line, or it could be this line, okay? But how we are calculating it? We are calculating the residue, okay? The sum of the squared residues, right? So you can see that b minus, I can't see it properly, y1, y2, y3 whole square, right? And for this also I will calculate the residue. And how I am deriving this, you can see that for every, now if I make this line as the best fit line, my residue is very high. So I will take only that line which is having the minimum residue. Okay. So this is the mechanism of having the best fit. Okay. So although we are making use of computer, but we really don't understand what exactly we are doing. Okay. But anyway, I think whosoever is working in remote sensing or any of this, everybody make use of the regression line, but people really don't know that how exactly the best line is calculated. You have dependent variable and you have independent variable. Y is equal to mx plus c. So accordingly, you generate the slope and you have the intercept. Okay. Now similarly, you have this clustering and association. Here basically we are not dealing with we are not giving any labeled data. Rather, we are making use of the clustering algorithm like k-means, clustering, isodata. There are so many algorithms which are being used. Even dbScan is also one of the software which is being used to identify the patterns in the data sets. Even what is that, similarity, cosine similarity is also one of the machine learning algorithm to identify the pattern, similarity measure of a given cluster. Okay, so it all depends upon the distribution of your data sets. Okay, so it's not that you are making use of labeled data, rather the data itself they are trying to analyze and providing you the clusters. So association is also is one of the algorithm which is being used in unsupervised learning. Then we have algorithms like linear regression, logistic regression, SVM. SVM, I think scalable vector. Have you heard about scalable vector machine? No. Basically, what we are doing is we are making an hyperplane between the two classes, and the distance between the two, the point where the distance of the hyperplane is minimum is called the support vectors. Okay. So this way we are trying to make use of the SVM algorithm to classify. Similarly, we have k-mean clustering and all those. PCA is also part of the unsupervised learning. Then we have application like image classification, prediction. We have unsupervised like recommendation system, anomaly detection, and of course self-driving cars and gaming, healthcare and all. So there are so many advantages and disadvantages of making use of the existing classification for this. So this is a classic example of the same unsupervised machine learning clustering. Supervised you have clustering and regression. So I will not go into the details. Now we come to the decision tree. Have you heard about this term, decision tree? Have you heard about the information gain which is being used to calculate the pixel purity, or let us say the purity of a particular tree? How many of you have used decision tree? Only one person has used? Okay. So basically what decision tree is, a non-parametric supervised learning algorithm. Why we call it a non-parametric? Why not parametric? Why it is called as a non-parametric? See, parametric are those where the data follow a Gaussian distribution, right? Non-parametric never follow the Gaussian distribution. Like for instance, there might be some like satellite data. Satellite data will always have a parametric means they will have a Gaussian distribution. You can have a histogram of a given class. But there are so many classes where you may not have the Gaussian distribution, like a digital elevation model, right? Or let us say so many classes, texture, so many classes where the data never follow the Gaussian distribution. If you want to make use of some of the historical data to be used in your classification, you cannot use it because it is not following a parametric, the Gaussian distribution, right? So if you want to make use of a non-Gaussian distribution data in your classification, then this will be called as a non-parametric supervised classification, right? So basically it is nothing but a hierarchical tree structure which consists of root node, branches, internal node and leaf node. So there are some software like ID3, C 4.5, you might have heard about it, and CART. These are some of the machine learning softwares which is being used. Even there is one software called C5, SEE5. Okay, that works. Now here, first you just see that this is the satellite telemetry of a bird, Jacobin cuckoo, which is considered to be Indian harbinger, Indian monsoon harbinger. Means it is the indicator of monsoon in India. So what we did is we put a sensor on this particular bird in order to see the movement of that bird, and it was presumed that this particular bird goes to South Africa, right? In Africa, from northern India, it goes to Africa. Okay, so what we did is, in our biodiversity project, we try to first put the sensor. So the sensor weight should be less than 2% weight of the actual bird. Okay, the weight of the sensor. So we purchased that sensor, and that was PTT sensor. So after putting a PTT, you can see that this is the sensor which was tagged on this particular bird. So there were two birds. Both are Jacobin cuckoo. They are very big. It was very difficult to trap this bird. And with the help of Wildlife Institute of India, we could able to trap this bird, put the sensor, and then let her fly. So you can see that these are all tracks of the bird flying here and there. And and in fact, after covering North India, it went to Western Ghats. From Western Ghats, it went to South Africa. And we have got all the how it traveled from northern part of India to South Africa. Now, the reason of this was the first time in the entire world nobody has done tagging of Jacobin cuckoo. This was the novel work, and that too we have used satellite telemetry. There is a sensor called Argos satellites which are being used to get the signals from that bird and putting on the dashboard. So, so you can see that maybe previous slide if I show you, and now you see. So these are all satellites, Argos satellites. Okay. Now you can see that it will sense. It will go to the ground station. From ground station, they will send all the data to the GLS. So from GLS, it will come onto my computer screen, and I could see that how the bird movement is tracked. The idea of doing this particular study was that by making use of how we can use machine learning algorithm to see what are the possible areas where it can go, okay, depending upon the climatic variables. That was the objective. So in this was one of the work we did on maximum entropy modeling using citizen science, use case on Jacobin cuckoo as an indicator of Indian monsoon, right? So this is some of the mechanism. What we did is we were only getting two tracks of these birds. One bird after some time we lost the data. I think we could not track that. But another bird which was continued till South Africa, we got all the tracks. But these are only two locations which we were getting. We wanted to have more locations in order to develop a machine learning model, right? You need to have more occurrence data in order to develop a niche for this particular bird. Okay, so we have used GBIF Global Biodiversity Infrastructure Framework. They have a lot of data which has been derived from citizen science approach. Means people have geotagged it and then they have shared that data in the global database. So we have taken all these citizen science and species distribution modeling, occurrence probability we have calculated. So basically what we did is we have used the world clip data, means all these 19 layers of the world clip, which is nothing but 100 years average data. We have the occurrence data. Occurrence data we are getting from the satellite telemetry as well as from the GBIF. Okay, and then we could able to identify what all climatic variables which are responsible for the occurrence of this bird, like how it is going from X place to Y place and all. So you can see that these are these are environmental variables and this is the test gain. So we could able to identify the parameters which are responsible for the occurrence of this particular bird in a particular place. So we have identified those climatic variables out of 20. The second thing is we have also performed the AUC, that is, which is the best model we are able to fit with the training data as well as the test data. So after doing this, we are able to identify that these are the areas where this cuckoo can be, it can be located, right? But the moment we made it to future scenario of RCP 8.5, where carbon emission is maximum in the country, in the world, then there is a possibility that this particular cuckoo may not get the habitat in this place, rather it might have some habitat in the southern part of the India, lowest southern part of India, and also it might get vanished from the South Africa. Okay, so you can see that this is the present scenario. See, these are 2 seasons. One is June to October, and then November to this. One point is it has got a breeding season. So during breeding, it comes to India, and after breeding, it goes back to South Africa. Okay, so you can see that November to May, you have some polygons, and then you can see some locations in the Africa also. But after this RCP, you may not find much locations of this particular cuckoo bird in this area. So what I mean to say is that you can make use of machine learning algorithms to identify the probable areas where the particular habitat can be found. And these are all probabilistic value. They are not, because since we are using maximum entropy, it only gives you a probability of the occurrence. If you have high probability, then obviously the success rate of finding that species in a particular area is quite possible. So this is a classic example, and we published this work with internationally also. So this is the mechanism of making use of. Had I used not machine learning, maybe I could have used simple algorithm, then I may not be able to really do I cannot generate scenarios by making use of the existing data sets. Another study, we did it on vector-borne disease. Here we have used machine learning algorithms. We have used both. The unsupervised learning was more predominant in this particular area. So, do we have dengue in Sikkim? Yes? Yes or no?
Yes.
Yeah. But not many cases, I think. Not outbreak. Okay. So what we did is, for the dengue related study, we have used machine learning technique for predicting the dengue outbreak in geospatial, and this paper was published in Current Science. So what we did is, we have taken the occurrence cases, and from those occurrences cases, we have related with the weather parameter. Means we wanted to find out what all weather parameters are responsible for the breeding of the vector-borne disease and how it can get there's the possibility of outbreak. So what we did is, we have done the multivariate regression of develop a quadratic model, that is the multiple attributes are responsible for the outbreak. So what we did is, we have used cubic spline smoothing for smoothing the data, and then generating what all variables which are responsible, like high temperature, high relative humidity and rainfall is responsible for the vector-borne disease. So these variables we could able to get by making use of the weather parameters. And after that, what we did is, these are all, actually we did not get the primary data, we got the secondary data. So from the secondary data, we could able to identify the clusters where the outbreak has happened. And then what we did is, we did the cosine similarity, means what all clusters which are having the same pattern, right? So this was the second level of unsupervised learning with similar dengue incidence pattern, and that is only possible if you have the vector data put it on a scatter plot, and you could identify that what type of pattern. In every block the patterns were different. Okay, so with the help of these patterns we could able to get the sum of the similar patterns in some of the blocks where the dengue outbreak was happening. And by making use of all those parameters, we use base classification to identify that where are the possibility of dengue outbreak. And you will be surprised to know whatever blocks we identified for the dengue outbreak, we would get the similar results over there. So that was one of the classic example that how machine learning algorithms can be used for identifying or for predicting the dengue outbreak by making use of the occurrence data as well as the weather parameters. Okay, so have you understood little bit at least? So these are some of the work, the unsupervised learning, and lot of classification was done, regression as well as classification was done in order to generate some of the information. Now we come to the artificial neural network. So this was some of the work which we did it more on the unsupervised learning, the one which was showing with the health related aspect as well as the bird thing. There also we have used entropy, that is information gain, in order to generate the prediction, the probability. Now ANN, I think you already know the basic concept is you have these neurons. You have all these, the connected neurons will help to develop an activation function. So that activation function will make all your linear combination into non-linear by making use of either a sigmoid function or a ReLU operation, and then you generate an output. So you can see that all these input parameters, they can linearly combine, and these weights are generated with the help of loss function. So basically, if you make use of loss function, the error for the prediction will be reduced. So you have to use the gradient descent and all these algorithms in order to reduce the loss function in order to have a better prediction. So this is the overall thing. I think this might have been covered by last Professor Biswas. The same thing, we have convolution neural network. This is part of the deep learning where you have more additional layers. So basically it consists of three parts. One is the convolution layer, second is the pooling layer, and third is the basically the activation function. So basically you can see that this is input, this is the actual backbone of the entire network. This is the convolution backbone, and this is head. So all these, whatever different type of classification or different thing, you do it over here. Okay, so this is the basic backbone. So where you have the convolution plus ReLU, then pooling, then convolution plus ReLU plus pooling. So this is the mechanism of doing the entire exercise. So you can see that what we do is we have a kernel, and then you have the image. So you try to run the kernel all across the whether you make 2 by 2, 3 by 3, whatever it is. So accordingly you make a dot map or an activation map. After creating an activation map, you will do the pooling, right? So what you will do in pooling means, once you have the activation map, you will try to have the single depth. This is the single depth slide. So what we will do is either we use max pooling or we use average pooling. Means the maximum value of this particular thing is replaced over here. So that is how you are reducing the dimensionality, means you are downscaling your convolution in order to generate the output. So basically you can see that there are different type of pooling operation like max pool with 2 by 2 filter, or you can use average pool. Means you could use an average of all the four values, and you can generate different pooling operation on this. So you have convolution, ReLU, and pooling. All these operations keeps on working, and if you have more deeper network, the information of better features can be extracted by making use of the convolution network. So you can see that, and then you have an activation. Now if you are working on a sigmoid function, you have value from 0 to 1, you normalize your entire data. Or if you are making use of ReLU operation where you go for positive values, you get rid of the negative one. So accordingly you can apply an entire CNN network and generate you can do the prediction, or you can identify different objects by making use of all these algorithms. Okay. Now these are some of the basic operations. We do it over CNN. You can see that first is classification. Classification means there is an area where you will say this is an airport, right? You are not identifying any object. Rather you are telling that this is an airport, or let us say this is a cat. The second is semantic segmentation. Semantic segmentation means, like this is, if you do a semantic segmentation, then you have different classes. You have aeroplane, you have runway, you have building. All these classes are nothing but they are clubbed into one class. Like you do semantic classification, like OBIA, object-based image segmentation. All these are algorithms which are used for segmentation. So this is semantic segmentation. So no object, just pixels. Here, no spatial extent. Similarly, object detection means you will make a bounding box of that particular object. You are not classifying it, but you are only identifying an object. Like for strategic purposes, you are trying to identify what is that object. Like if it is, like let us say here dog, cat. Here we can see that this is an object which we want to identify. Like this is an aeroplane. You have the bounding box. Then you have instance segmentation. Instance segmentation means you have a bounding box and you are also having the overall pixel. So you can have a multiple object detection as well as instance detection. So this is the overall terminologies which are being used in order to classify any of these areas. Either it is a object detection or classification or semantic segmentation or instance segmentation. You can make use of all these algorithms. Now we talk about RNN. RNN is basically, it is back and forth. It works on the with the sequential data. It is slightly considered to be a better mechanism. So here you can see that all your outputs are again inserted into your input. So this is the way we have two parallel CNN which works on top of it. So basically it is specially designed to handle the sequential data using concept of forward and backward propagation. And you can see that it has got, by using the same parameter across all steps, RNN perform consistently across inputs, reducing parameter complexity compared to traditional neural networks. So it is being used for text translation, text completion, as well as sentiment analysis. So these are basic structure. I think you can get this structure anywhere. You can Google it and you can have all that information. Then we have LSTM, long short-term memory network. This is quite good model because whenever you want to do the temporal analysis, like if you have historical data available with you, and you see that some of these historical data needs to be processed in order to get the patterns. So for that, what you can do is you can make use of LSTM. In ISRO, we have used LSTM for many applications, especially I will show you one application where 23 years of data was used and there were a lot of dropouts in the data. So we could able to fill those dropouts with the help of LSTM network. So it is quite good in order to have a long dependencies data is available, then you are able to produce good results. So here it has got cell state, input state, forget state and output state. All these states, anyway, I think I was told that you already know, so you don't have to. And then you have transformers. Transformers are nothing but encoder or decoder. So encoder, what is the role of encoder? Encoder summarizes all the data and decoder reconstructs the data. So that is the basic concept of the encoder and decoder. So there are a lot of transformers which have been used, and it is a concept of attention to understand the long-term dependencies on sequential data. So I think it is being used extensively, and there are so many applications where this Gen AI transformers have been used. I think another one is GAN. GAN basically works on generator and discriminator. What it does, it generates the image. Generator will generate the image, discriminator will evaluate the image, right? So both, it will keep on generating and discriminator will tell whether it is a fake image or it is correct image. So that entire process continues unless the correct data is generated from the given input data. So that is the basic concept of the deep learning GAN network, and a lot of applications have been developed by making use of this deep learning. In fact, in videos you will see a lot of GAN as well as this transformers have been used for generating the, like for this fake images and all those images are being created by many. So these are some of the examples for the AI in earth observation, like agriculture, forestry, water resources, renewable energy, satellite data processing, disaster management, as well as land resources. Now here I would like to give you an example that NDVI time series forecasting using LSTM. So here LSTM has been used to forecast. Now you can see that, do you know NDVI? Normalized difference vegetation index. So from a given NDVI profile, you are able to tell of a given crop field how many crops they are sowing. Okay. So like if it is bimodal means 2 crops are there, if trimodal means 3 crops are there. So depending upon the mode you can see that how many crops are sown. That is one. Second thing is, there is in the data, once you have trained the LSTM, means 23 years of data profile is ingested into LSTM, right? So after ingesting the LSTM, without LSTM, there were a lot of dropouts which was coming in the data. The dropouts could be because of cloud, it could be because of snow, there could be a number of problems, because when you are stacking all the layers, you may not get the correct scene. That is one. So first you have to clean all the data. The second thing is, if you have the data up to, let us say, 2023, so it will give you the projection that in next year what will be your profile on the basis of your past data. So long-term dependencies, all that will be processed and it will give you the prediction. So that is the beauty of making use of LSTM. You can directly visit this particular Vedas portal which is hosted by SAC Ahmedabad, and they have already provided this. So you can directly see the prediction of a given crop in a given year. Like if you are working on a crop yield estimation, by making use of this profile you will come to know that how much crop, like how many crops will be sown over there, and what could be the probable area where you have this particular crop. So these type of things one can evolve or one can infer by making use of deep neural network. Okay, is it clear? So this is the classic example. Another example is, I think you might be aware of the direct seeded rice. Government of India in Punjab, Haryana, they told that people should not make use of the transplanted rice because it takes a lot of water. Now because of the water scarcity, what they suggested is you use direct seeded rice. Okay, so in the entire agricultural field, it was difficult to discriminate direct seed rice as well as transplanted rice. So in order to discriminate this, we have used random forest to identify those areas where the direct seed rice is there or transplanted rice is there by making use of microwave data sets. So this is a classic example by making use of random forest in order to identify or to discriminate both the type of rice. Okay, because if you are able to identify, then you can tell the government that they have not used the water, rather they have used direct seed rice. So it was difficult by making use of the existing algorithm to discriminate both the rice. But with the help of random forest, we could able to discriminate both the forest. Another approach is the precision agriculture. I don't know whether you are aware of it or not. Precision agriculture, basically it talks about AI and IoT. IoT nothing but Internet of Things, where you try to capture the data at real time interval. Means you can put the sensor. We have developed different IoT devices, in my center, where you can get the soil moisture. That is one. Second, you can get the NPK, how much nitrogen, phosphorus and potassium, as well as what is the soil temperature. That you can directly get from a sensor. and that sensor for every 1 minute it can give you the values, and that is directly connected to an AI platform where automatically if you are putting those sensors in a field, if you put these sensors all across the, like let us say 5 to 6 sets of sensor you put it, then it will tell you that how the different variability is there in those areas, and wherever there is deficit of any of these NPK, with the help of drone you can make use of robotics in order to spray those fertilizers in those areas where it is deficient. So this way you can develop a full chain of the processes by making use of IoT, by making use of AI, as well as by making use of robotics. Okay, so this is the classic example, and we are working in our this thing, and robotic can also be used by making use of drone, where drone will spray only those areas where the deficit of particular fertilizer is there. Okay, so this is the example of making precision agriculture by making use of AI. In fact, crop yield estimation is one of the most difficult part of the government of India. Why? Because they are still dependent on crop cutting experiment. Crop cutting experiment means in a particular district, they do crop cutting and then they do the weightage and then they extrapolate the entire value for the entire district. But that is not the correct mechanism. They have to use AI based method in order to develop a model where for every particular area you are able to get the crop yield. So there are some 5 models which are proposed by YesCheck program of Ministry of Agriculture and Family Welfare, and they are trying to make use of AI based algorithm where they are able to get those the actual crop yield estimation without getting dependent on the crop cutting experiments. Okay, so these are some of the developments which are taking place. Now here I would like to tell you about the CNN based butterfly identification. Here in our biodiversity project, the same project of satellite telemetry, we were having a lot of butterfly data. Around 1300 butterfly data was available with us, and then we have developed the CNN model. We have augmented this butterfly data into around 20,000 more images, and from there we could able to develop a model which could identify a butterfly by just clicking a photograph. Okay, this was the pilot study, we did it, and because of this training data, limited training data, we took, this is the mobile app where we have used SQL Lite DB as well as TensorFlow Lite model. That was long back, and here you click the photo, load from the gallery, view species, and you are able to get all the information of that particular butterfly. So this work we did it long back in 2019. 20. So at that time I think TensorFlow Lite was quite common and we could able to get, but the only limitation of this particular model means we were having very limited training data. Only 1300 photographs of the butterfly was available. And just similarly we started doing for the birds also. So birds data also, it is very difficult if you take the photograph of bird flying. So it is not possible for you to really identify the butterfly, the bird, unless until you have a still photograph where you are able to recognize that. So those type of things can also be done if you have good amount of training data available, and then you are able to create those type of information. Now another example was rooftop solar potential using 3D city model. I think 3D city model is one of my favorite subject, although it is not covered in this particular topic. But here there were 2 problems. One is how to get the height of a building and how to identify or how to create a 3D model of the entire landscape. So for this, 2 things were there. We make use of Cartosat data, Cartosat stereo data to get the height, and Cartosat 3 data for identifying a building footprint. Now building footprint extraction is very difficult from a high resolution data because of so many aspects, because there could be a problem of occlusion, there could be a problem of, if it is not a nadir view, then your building footprint may get dislocated. So a lot of limitations are there. So here we try to use the YOLO as one of the CNN based model where we could identify the building footprint. It gave some level of some level of good results. So you can see that all these buildings were we could able to get the rooftop, and we could able to classify them into high-rise buildings. So information extraction. The another thing is we have done it for CNN for extracting snow areas. Snow areas also very difficult because you have different type of snow areas, and this we have to do it for IRS based data, and that too with a very high temporal interval because you are getting very high frequency. So we could able to identify all the snow areas. That too with there might be fresh snow, there could be old snow, so different type of snows are there, but we aggregated them into one class and we could able to identify the snow dynamics of a given area by making use of this particular CNN model. So this is another example of super resolution. What we did is shortwave infrared as well as LIS4 data. Means LIS4 data was having a resolution of around 5 meter and LIS3 SWIR was having 23 meters. So we wanted to bring all the spectral information into a spatial resolution. So for this we have used the machine learning algorithm. The important part is that how we can take that texture. The texture information of LIS3 was taken back to the LIS4 data. So if you are able to get the textural information, means the contextual as well as textual information, you embed into the high resolution data, you are able to get those super resolution information, and you can see that the level of this is the SWIR data of a very coarse resolution, and with the help of LIS4 we could able to get high resolution, means a super resolution of the SWIR information by making use of LIS4 data sets. So this is a classic example of making use of machine learning algorithm for getting the info. Another example is landslide mapping. Landslide mapping, I think you can, on the way I could see that there were a lot of landslides which were there, and identifying the landslide is very difficult. So at NRSC they have developed a model that is Deep Lab. In fact, Deep Lab V3 model is already there. So they have put the training data of some of the areas by making use of NDVI and GNDVI. That is the green vegetation as well as the NDVI. Both data sets were inserted as a part of training data, and they could able to identify the landslides in a given area. So this is one of the good work, and they are trying to create a lot of training data for other regions also. So this was one of the exercise which was done, and in fact a lot of GLOF studies also people are making use of Deep Lab V3 model, where they could able to identify these type of features in a given this thing. Okay. Now then another study we did it for the chain detection. Like for instance, for in Delhi area, they wanted to identify the change area in a given point in time. So what we did is we developed some machine learning algorithm to identify the change detected parameter. You can see that this is T1 and T2. So you from these two images, we could able to identify that there is a change in this particular area by making use of the machine learning algorithm. So these are very simplistic study which can be done. But see, the problem is not with T1 and T2. The problem is when you have T1, T2, T3, T4, T5, how many times you are supposed to do it. So for that you have to make use of the CNN, and that is only possible if you are able to get those pure pixel, or let us say labeled tiles, generate those train data and then apply a CNN model. Then only it will give you some good results, otherwise it is very difficult. And moreover, most of these pre-trained models which are available in the, maybe you can get from the sites and all, they have been trained by so much data, you cannot think of it. And in order to process that ANN model, you need some 5 petaflops of computing infrastructure to train that model. Right? So even if you are intent to develop a real heuristic model, you have to have a good processing systems with you, which can process around 2 petaflops or 3 petaflops of the computing resources. So all these CNN based thing is not limited with the data, but with the computing resources also, so that you are able to develop. So what people are doing is they are making use of the pre-trained model and putting some data and then generating the result. Most of the results what you see in India or in so many other countries, already pre-trained models are available. You put some data and you are able to get some level of information. In fact, we could able to work on a vegetation growth modeling is one of the most difficult project which we were involved. We have taken one pre-trained model and inserted some data sets into it, and I will not give you the name of that model because we are working on that, and you will be surprised to know we really got very good results. And only thing is, if we really want to train our own model, we need, I told you, 5 petaflops of computing resources are required, which we don't have at this point of time, right? So if you really want to work on these type of CNN or RNN and you want to develop your own model, you need to have a good computing resources at your center. Only then you can attempt these type of studies. Okay, so because anyway structures are already defined. Only thing is the training of the entire network is important. So now this is another monitoring of vacant land in metropolitan city using VHRS and DL model. Here also we developed within Delhi, lot of dependencies are there in order to identify a small area. In fact, they wanted to identify only 100 square meter area, or let us say 50 square meter. If it gets encroached, we have to identify that. How we can identify? If it is happening at regular interval, we don't have satellite images. We have satellite images of every 1 month or 2 months of time, and that too, it is not very high resolution. So working on these type of areas, you need very high repeativity of the satellite data, and after that you also need good training data so that you are able to identify. So some level of information was done into this particular study, but we really have to see that how we can work in a better this thing. So there is another study which was done by some of the person from outside, AI for predicting modeling, that is with wildfire spread modeling. Wildfire spread prediction is one of the study where n number of parameters have been used: elevation, wind direction, wind speed, temperature, maximum, minimum, humidity, precipitation, drought index, vegetation, population density, energy disease, and previous fire mass and fire mass. Even NRC is also working on forest fire spread modeling, and we have also developed a deep learning model, but we are yet to calibrate it, or we are yet to validate it. Once it is validated, we are able to get a good accuracy. So similar type of work is being carried out in India also in order to work on, because wildfire is, I think in America also you might have seen Los Angeles, very tragic one. But in India also, in Uttarakhand and all, lot of forest fire used to happen. But in Northeast, I think they are only limited to shifting cultivation, which never gets into the wildfire. But in Uttarakhand, I think this problem is happening quite frequently, and we need to have a CNN model in order to do the prediction of the wildfire. So I think this is one of the study. The last slide is for AI for rescue resource management. Here you can have a pre-image, post-image. You are able to get the information with respect to no damage, minor damage, major damage, as well as destroyed. And that is only possible if you have good training data, especially during the earthquake. Most of the cities, like if they are prone to earthquake, if they have these type of data sets, you can train this data and you are able to get different category of the classes which can be used for identifying the damage assessment or rescue management. So these are some of the use cases. I was a little bit fast. Reason being is that I had to reach airport by I think 3 o'clock or so. If you have any questions, I can take that. Thank you so much. Any questions? Yes, yes.
First of all, very interesting lecture.
Yeah.
So you talked about many models, but for a given problem, how can we decide that this model is
but you have to define your problem first. Like for instance, if you want to generate a synthetic image, you will go for GAN, right? If you want to work on a long series data, like if you have a historical data, work on LSTM, right? If you want to work on image segmentation, go for CNN. Okay, so they have already defined models which are meant for, and I would suggest you to go for a review paper. There is already some good review paper which are available where list of models are available. In fact, for building footprint extraction, YOLO is one of the model which is being used for identifying the building footprint. Right. So if you refer to so many studies and you are very clear what exactly you want to do. You want to do for image recognition, or you want to go for segmentation, or you want to go for object identification. For all these studies you have different models which are available, and since if it is a pre-trained model, because you cannot create your own model, because you need to have a high computing resources to run the model. Rather you make use of pre-trained model, run over it, and then you are able to get the information.
So for the biodiversity project that you did,
Yes.
the cuckoo bird,
Yeah.
you used a machine learning.
We use machine learning.
Can it also be done using some deep learning?
Yes, deep learning also. So, but for deep learning you need a good amount of data. But here our objective is to identify the predictive habitat of this particular cuckoo bird with the present data, how it will behave in the future climatic scenario. So that was the basic. So habitat suitability using machine learning was the main objective, and all these cuckoo data as well as data which we got from the satellite telemetry as well as from the GBIF, we could able to train the model by making use of maximum entropy, and this we could able to predict in which area the same niches, same areas where there is a probability of that particular bird. Even lot of animals are getting into different, their habitat is going to change in coming years, and lot more effect is going on. People are not realizing it, but there are so many, like for instance we talk about lion, we talk about tigers, so many different type of populations are getting affected because they are not getting adjusted to the climate change. Okay, so that is the reason why you need to really see the what are the environmental envelopes in which they can have their habitat, and how it is going to change with the effect of the climate change. Okay, so there are a lot of interesting areas where people can work on machine learning, deep learning, all these given algorithms, and you can do wonders in this particular area, because this area is still under progress, and one can do wonders. So with this, I think, thank you so much. Any other question? Yeah.
What type of model can be used to study climate change or predict the climate change?
See, they are all climate change models are like numerical weather forecasting models. They are not making, I am not aware whether they are making use of AI models or not, but they are all parameter driven models, like numerical weather forecasting models. All these are already globally they are running, and they are sharing their parameters to different countries. Okay, like GFS models, so many global forecast models are there, and in fact in India IITM as well as IMD is responsible for making use, because you cannot run the global model. These are all regional climatic models. You cannot run it for a particular area, rather you have to run it for the entire region, or let us say a bigger thing. So for that, in order to process these models, you have to have a big computing resources. So what you can do, you can make use of the existing outputs to further work on, like for cyclone prediction, or for ITCZ, like precipitation, how precipitation is behaving in different continents. So you can work on those data sets. So I think AI, I'm not very sure to what extent they are making use, but numerical forecasting models are really, they are data intensive, and you have to really make use of good computing resources to run those.
For prediction for tsunami?
For?
Tsunami.
Tsunami, tsunami there are already, I think tsunami N2 model. There are so many models are there where they are making. I'm not an expert in that area, so I may not able to comment, but there are already existing models like weather forecasting models are there. Similarly, tsunami models are already there. I think, and this Inquires is already working on tsunami N2 models, and they have, I think, so many other aspects. So I'm not very much aware of those aspects. Yeah, thank you.
Sir, my question is that NRC is working on any climate change or any
Yes.
different emission scenarios in future prediction.
Yeah, they are working. They have a group called NICES, and they have a portal where they are providing around more than 20 environmental climatic variables in the open data. You can visit NICES portal. NICES portal. They have a team of earth sciences, and they are working on all these climate related work.
And any flood related modeling?
Flood related modeling also, because in NIAS, there is a portal called NDEM portal, National Database for Emergency Management. So whatever the flood forecasting, or let us say cyclone or lightning or forest fire or landslide, all those data sets are available in NDEM portal. You can directly access, and whenever there is a flood, automatically within a span of 2-3 hours they are providing the inundated maps in the public domain, and they are directly sending this data to MHA, Ministry of Home Affairs. Yeah.
Sir, any kind of data for road infrastructure?
Yeah, road. I think lot of transportation models are already available, and they are making use of already existing training data. Better if you are able to create those road infrastructure, like some good training data. I think, but you can make use of the existing training data model which are there globally. So yeah.
Sir, what about meteorological data?
Meteorological data?
IMD meteorological data isn't that free, sir?
Pardon?
The IMD meteorological data isn't that free, sir?
It is, IMD data is free. You can directly download from the IMD website. They are providing a graded data. It's an interpolated data basically. They are not providing the AWS data directly. Rather, they are providing a graded data. Okay. So you can directly download the IMD data from. You can visit IMD website, or you can even visit IITM website also. And even in ISRO, you can visit MOSTEC website. MOSDEC, we have all the INSAT 3D and 3DR data sets available. So I think even they have AWS data available. So some of the weather station data is you can directly download from the MOSDEC website from SAC and Governor. Okay?
Sir, for flood inundation map or a northeastern survey, can we get
Pardon?
flood inundation map?
For inundation map,
Yes, for northeastern survey, can we get the data?
yeah, please put a mic, I am not getting.
Sir, for flood inundation map, no? For
Yeah.
northeastern area, where can we get the data?
Where you can?
Get the data.
You can get from any SAC also.
So in any sec, it is only for the Assam area and Sikkim. For Arunachal, it is.
But from NRC you can directly get. NRC you can
I've
get.
gone through the portal, no, but I didn't get for the Arunachal area, Arunachal region, Arunachal Pradesh.
Arunachal Pradesh, you send email to me.
Okay.
I will try to arrange data for wherever region, from northeast region. I will talk to NESAC director, I will talk to NRC director, and if it is required, we will give it to you.
Okay,
Okay?
thank you, sir.
Yeah. 11. Okay, thank you so much. Yeah.